Hello guys, I think this is the sixth video. This video is basically just going to be about learning all the squares from 1 to 100, hopefully. If not, coming up with an easy way to figure them all out. You could probably extend this methods or whatever to bigger squares like 101, 102, 103, 201. But I'm basically just going to apply it to 1 to 100. And there's different methods and concepts. Well, we'll see. So let's get started. First, you should probably know all of these. If you don't know how to multiply numbers from 1 to 9, then I don't know how you've been multiplying all this time. These are your standard numbers, and they're like the lowest tier, the squares. So I just recommend that you know them, all of these. Yeah. As you may know, 5 times 5, you're just using the 25 thing. But yeah. Other than that, this is all just simple stuff you should have learned in grade school. All these squares are like the most basic it's gonna get. So moving on. Now the tens. Hopefully you know also these three, because they also taught them to us in grade school. If not, don't worry, these all have an easy method to figure them all out. And hopefully you won't have to do it for 100, cause 10 times 10, obviously it's 100. You just add that extra 0 to that 10, and you get 100. So what are you doing with all of these? Well, first you have 1 and a random number. In this case I chose 4. Oops, wrong tool. I chose 4. Oh my god. Need my eraser tool. And this tool. Okay, another pointer. Okay, so you're basically doing the same multiplication strategy. So 4 times 4, that's 16. 4 times 1, 4. 1 times 4, 4. So it's 8 plus 1. It's 9. 1 times 1 is 1. And hopefully you figured out that to get the first number, all you have to do is multiply the 4 times 4. And and obviously you get 1 as a remainder. And since it's just the 1 that you're multiplying with, all you're really doing is adding 4 with 4 as the remainder. So it's just a 9 and the 1. So let's try that with all of these. Okay. So what's 3 times 3? 9. What's 3 plus 3? 6. And 1 times 1? 1. Okay. And we figured this one out. And this, you could approach it two ways. How I just said. If not, since it's a 5 times 5 problem, all you have to do is 1 times 2, that's a 2, and then the width of 25. And this, actually, I recommend that you memorize that. Well, most people probably don't know what megabytes are nowadays. The way that I remember this, it's for the PSP, they had these 256 megabytes. 256 is 1/4 of 256 megabytes is 1/4 of a gigabyte, which I doubt some people might know, but that's how I remember. If not, you could always do 6 times 6, 36, carry the 3, 6 plus 6, 12, plus 3, 15, you get that 5, and you carry the 1. 1 times 1. 1 plus 1, 2. Okay. So here, what's 7 times 7? 9, carry the 4. 7 plus 7, 14, carry the 4, that's 18. 1 plus 1, 2. Okay, this one now. 8 times 8, 64. Carry the 6. 8 plus 8, 16. Plus 6, 22. Carry the 2. 2 plus 1, 3. Now one more. This, you could also do it another way. I'll probably show you. So just think of 20 times 20. Hopefully you know that's 400. So 20 times 20 is 400. So 19 times 20, hopefully you know that when you multiply with one less, that means you take away, in this case you're subtracting 20. So 400 minus 20 is 380. And when you go even one down for the other one, you're subtracting 19. So now you have 361. Or you could always add 20 plus 19 to get yourself 39. 400 minus 39, you get this. If not, you could always apply the other method. 9 times 9, 81. 9 plus 9, 18. 18 plus 8, 26. There's your 6. Carry the 2, you get 3. Okay. Moving on. No, these are a little more complicated as you might imagine. But these are practically the last ones you actually have to memorize before a pattern starts to develop. So for this one, you could apply the same method of the 20 times 20 but backwards. So instead of subtracting 20 and 19, you add 20 and 21 since you're going up. So what's 20 plus 21? 41. So there's your answer. You could actually just keep on doing that pattern. But yeah. 22 times 22. Well, you could factor out 11 and you get 2 times 2, which is 4. So it's basically just 4 times 121. 484. Okay, now this one's a little more tricky. You could always go ahead and just do the multiplication trick. I'm thinking if there's another way. Probably not. So, okay, let's just do the regular multiplication. 3 times 3, 9. 2 times 3 times 2. 2 times 3 plus 2 times 3. 6, 12. Carry the 1. 4 times 4. 2 times 2. 4 plus 1, 5. For this one, I guess you could, let me think. You could probably go ahead and do the same thing you did for the 22 times 22. Factor out a 12. If not, you could always factor out, let me think. thing. Well, whatever. You could factor out the 12, you get 144. You get 2 times 2 in the end, that's 4. So 4 times 144. 144 times 2, 288. 288 times 2. And this one is just a 5 multiplication. 2 times 2. No, 2 times 3, 6. You get that 25, and you're done. Okay. So now for the interesting part. Oops, I don't want to do that. You could think of 25 as a mountain that you climb when you're squaring numbers, I guess. What the heck? And when you get to 26 is when you start going down the mountain. 25 would be the peak. Look at 24 times 24. That's an interesting number, right? I know, right? So for some reason I feel like putting a 6, and now that I look at 24, oh wait, that's the answer. Kind of interesting. Let's go one number bigger, 7, because, you know, there's no more room. Look at 23 times 23. That's an interesting number too, right? There's your answer. 28 times 28. Looks like you could probably add a couple more numbers to 700 and it'll still be in the 700. So let's keep 7. Go with 84. There's your answer. 29 times 29. Well, if we look at 21 times 21, it's a 441. And there's no more room in the 7. So. And obviously 30 times 30 is 900. Okay, so you might be wondering, what rule did I use? What was I talking about? Well, it's simple. Just give me a second. Basically, numbers, after they get to a certain point, they start repeating themselves. Are you following me? Okay. They have patterns. Some might be longer, some might be shorter. This pattern just happened to be every 25, well 50 because if you think about it, it's going down a hill and you have to go up a hill and then go down to actually finish. So the pattern here will actually be every 50. But the first 25 numbers, you can just mirror them across the next 25. They'll be exactly the same. Well, the last 2 numbers anyway. The first number you can get it using common sense. For example, the next number should be around 50 away from this one, because you know you're in the, if you actually add 25 with 26, you get 51. So yeah, it should be like 50 away. So it's obviously still going to be in the 600s. So you keep that 6 and just copy the next 2 numbers from here. And it's the same thing for the next numbers. You're gonna add like 50 some, so it's obviously gonna be in the 700. So we get the 7 and we copy the 29 from the 23. Basically at this point, if the basically if they add up to 50, well, if they add up to 50, that means they both have similar numbers at this point. It's not really like a rule or anything, it's just like, well, just listen to me. Because 24 times 26, 50, 23 plus 27 is 50, 28 plus 22 is 50, and blah 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 blah. Okay? Okay, so moving on. I'm not gonna cover the 30s right now. I'm actually gonna cover right now. What can I cover? You know what? Well, let's start at 50. Hopefully you know 5 times 5 is 25. Add that 0. Voila, you're done. Okay, so now let's make some. What happens if we actually square this? Well, you get 2500 minus 100a plus a squared. Looks a bit complicated, you might think, but it's not. This is basically saying that the higher a is, that for every a that's away from 50, you're going to take away another number from this. And then you get the distance and you square it. Okay. So let's take 48 for example. Let's square that motherfucker. Okay, so the distance from 50 is 2, right? So 25 minus 2. That's a hard one. And 2 squared. There's your answer. Wasn't that hard, right? And it's basically the same thing when you're adding a number to 50. For example, 50 plus a squared. It's basically the same thing as the top formula that you're seeing, but instead of subtracting 100a, you're adding 100a. That's the only difference. Okay? And that's how we can get, that's how an easy way to get the squares from 31. Well, like, it's very, very, very easy to get 41 to 60 just by knowing your squares from 1 to 10. Well, I should probably say 40 because 40 is kind of an easy one as well. So you can know these squares just by knowing these squares. Makes sense? So let's go ahead and fill in the blanks. What's 41 squared? 25 minus 9. 9 squared, is 81. 42 squared. 25 minus 8 and 8 squared. 43 squared. At this point you can just add one number or whatever. You're subtracting 7 and then 7 squared. 44 4 squared. 19, and then 6 squared, 36. And you can go on and 36. On and on and on and on and on. This also applies to the 30s. So you only need to know your squares from 1 to 25. That's why I kept on stressing it. So this, how far away is it from 25? 19. So you get a 6. Wrong. Because you forgot 19 squared. That's 361. Carry the 3. There's your answer. 25 minus 18, that's 7. But that was simply wrong, because you forgot 18 squared again. Oh no. 18 squared, it was 324. So carry the 3. And at the same time, you can memorize, this is 2 to the 5th. And this is 2 to the 10th. This is exactly 1 gigabyte. How many megabytes equals 1 gigabyte? So if you're like really into computers and stuff, you might be able to memorize this one easily. Okay, one more. So 25 minus 17, 8. 800 plus 17 squared. 17 squared is 289. There you go. And of course, just like 51 or 60 have the same rules, but you're adding, is the same thing for numbers bigger than 60. For example, 61. What's 61 squared? Well, there's actually 2 ways of doing it. You could use 60 as a reference and add 60 and then 61. Or you could do this. So 25 plus 11. 25 plus 11. That's 36. But hold on a second. 11 squared is 121, so you're carrying 1. Oh boy. Oh no. What about 62? Well, 12 squared is 144. So you're practically just, you get 3700 plus 144, which is 38. And this goes on and on. You could probably apply up to 75. So okay. Now we're like in the big numbers, the last 25 numbers. First, you should probably know 75 squared. 7 times 8, 56. There's your answer. 80 squared. 8 times 8. 85 squared. 8 times 9. 72. And then add that 20. Oops. 90 squared. 81. 2 zeros. 95 squared. That's a little more tricky, ain't it? Well, all you really have to do is the same thing as the 5s. 90. 10 times 9. 25. Okay. So hopefully you knew that before. So the last 25 numbers. So let's start with 100 squared, since that's the closest easy number there is. You have 10,000. Okay. So now what happens if we use algebra on this? Oh no, algebra. No. Well, you have your 10 squared minus 200a plus a squared. That looks familiar. Well, it should be. The only thing that changed is the first number squared, you know, your reference. And this, it doubled, which makes sense because you went from 50 to 100. So you could basically use any multiple of 50 as a good reference. Why? Because they're all multiples. They're all going to give you a solid minus something a squared. For example, with 50 was minus 100a, or plus 100 if it's bigger. With 100, it's minus 200a, and if you go bigger, it's plus 200a. So now let's use this. Let's say we have 93 squared. Well, you will have to subtract 14 from 100. Or just this number, the difference from 100 to 93 times 2, which is still 14. So 100 minus 14, can you solve this? It's 86. And don't forget those extra zeros. Whoa, 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 but wait. You still need to add a squared. There you go, there's your answer. So now let's go a little lower. 79. Okay. So it's actually 21 away. So it's gonna be 100 minus 42. What does that equal? Oh, 58. And then 21 squared. Hopefully you remember it's 441. Carry the 4. Have 62. Oh, it's almost like magic. So if you have actually been listening throughout, hopefully now you're able to do the squares from 1 to 100 and hopefully beyond. And I just want to remind you guys that the numbers repeat themselves. So just pretend this is 25 right here, and this is 50, and this is 75 and 100. After 25, it's basically just a mirror image, and after 50, you finish one up and down of the thing. And this actually goes on forever and ever and ever. Just that the numbers get slightly bigger, so the rules might change. Hopefully you're able to know how to adjust it. But basically this is how the pattern works. Once you get to a certain point, it starts repeating. And once you get to another point, you finish one cycle, and the cycle starts all over again. This is for the last 2 digits. There's patterns for the last 3 digits, 4 digits, blah 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 blah. It's just that the patterns are more, longer, messier. So it's best just to use this. I hope you guys learned something. If you have any comments, questions, or concerns, feel free to leave in the comments sections, and I'll see you guys next time.